Hi students, welcome to our class. I hope everyone is safe. From this video, we will be starting our second unit, optics. So optics is the physical science where we will be learning about the properties and phenomena of invisible and visible light. So light, we can say that it is a form of energy, and the path traveled by light, we call them as ray of light, and a group of rays we will be calling it as a beam of light. So if some objects emits light, then we will be calling that as source. And the properties of light already we have studied in our lower classes, that is, it holds the property of reflection and refraction. So in this unit we will be learning about scattering of light, images formed by convex and concave lens, human eye, telescope and microscopes. So let's start with the properties of light. So totally there are 8 properties that are associated with light. The first property is, as I told before, light is a form of energy, and light will travel in a straight line. Light will be traveling in a straight line. So light does not require any medium to travel, so that we can say light can travel through vacuum. So what will be the velocity of air, or else what will be the speed of air speed of light in air or vacuum? The speed of light is represented as c, which is equal to 3 into 10 to the power 8 meter per second. And the fifth property is, the one important property, light exhibits in a form of wave. So light is in the form of wave, so that we can express that in the form of c equal to v lambda, where c is known as the velocity of light, v is known as the frequency, and lambda is nothing but it represents the wavelength of the light. And so normally invisible light is a composition of different colors, so that different color lights will be having different frequencies and different wavelengths. So that different color lights will be having different wavelengths and different frequencies. The seventh point is, among the visible light, normally if we see the visible light, it seems to be white in color. It seems to be white in color, but actually that is a composition of 7 colors that we call it as rainbow colors or vibgea. So at one end it starts with violet, and the another end it ends with red. So that we can say the violet has the lowest wavelength, and the red color has the highest wavelength. And the final point is, suppose when a light incident on interface of two mediums, then the light is partially reflected and partially refracted, which means one part gets reflected and one part gets normally refracted. Of light. When a light from one transparent medium enters into another oblique medium, the path of the light gets deviated. The deviated path of light is known as refraction. The velocity of the light varies according to the medium. So we can say that the velocity of light is more in rarer medium, and the velocity of light is less in the denser medium. Let us understand refraction with a small example. Let us take an incident ray which is falling on a glass medium. So which means let us consider the air medium as rarer medium and the glass medium as denser medium. When a ray of light passing through air and glass at the surface, it normally gets deviated. The dotted lines represent the actual path of the light. Due to the difference in their refractive indices, the paths get deviated. This deviated ray is known as refracted ray. So the refraction normally obeys 2 laws. We call that as first law of refraction and the second law of refraction. The first law says that the incident ray, the refracted ray and the normal on the surface of refraction lie on the same plane. So which means all the three, the incident ray, the refracted ray and the normal is lying on the same plane. The second law of refraction states that the ratio of sine of angle of incidence and sine of angle of refraction is equal to the ratio of refractive indexes of the two media. So as the medias are different, the refractive indexes also vary. So that can be expressed as sin I by sin r equal to mu 2 by mu 1. So this is also known as Snell's law, where mu represents the refractive index of medium. So that simply we can say that the sine of incident ray and the sine ratio of angle ray is equal to the ratio of refractive indexes of two media. So the refractive indexes determine the speed of the light. So as I said before, when the refractive index is more, we can call that as denser medium, so that the velocity of the light is less. When the refractive index is low, we can call them as rarer medium, so that the velocity of the light will be high. So when the light enters from a rarer medium to denser medium, the refraction will be towards the normal. If this is inverse, when the light ray enters from a denser medium to rarer medium, the refracted ray will be outwards of the normal. So these are all the points that we can infer from second law of refraction, and the second law of refraction, that is also known as Snell's law, is one important law of refraction. Dispersion of light. We all know that sun provides fundamental and natural source of light. When the source of light produces a single color, we will be calling that as monochromatic light. The source, we will be calling that as monochromatic source. So a composite source produces a white light which contains different colors. The sun always provides a composite light and which has different colors or different wavelengths. So a white light or a composite light refracted through any transparent medium. For example, let us take water or glass. It splits into different component colors, and the splitting up of colors is known as dispersion of light. The splitting up of white light into several colors, we call that as dispersion of light. So the band of colors that are associated with the dispersion, we will be terming it as spectrum. So our spectrum consists of mainly 7 colors that we call it as VIBGR, or also known as rainbow colors. It represents violet, indigo, blue, green, yellow, orange and red. So they are not being interchanged, so the same order the band will be appearing. So from this we can identify that the angle of refraction is smallest for the red color and it will be highest for the violet color. So as according to Snell's law, we can say that the refractive index is mainly dependent on the wavelength of the light. As the wavelength of the light varies for different colors, they composite into a single white color. This we call it as dispersion of light.